And we are live. Hey everyone, I am Ritvik from PyImageSearch.com and welcome to the first ever live lesson where we talk about Introduction to Deep Learning. Today's session will be hosted by Devjyoti, who is an author at PyImageSearch and an open source contributor. He loves working with deep learning models and diving deep into theory and practice. So without further ado, I would love to welcome Dev uh, to the stream and leave the explaining to him.
Thank you for the awesome introduction, Ritvik. Hey everyone, and I hope you all are doing well. Thank you so much for joining us today for PyImageSearch's first ever live session. I'm privileged to have been given this opportunity to lead this, and I hope all of you have a great time throughout this session. Above all, I hope that the choice you made of attending this session was impactful to your life. I'll be tending to your queries throughout the session, so feel free to post any questions that you have in the chat section and ask away. Let's keep this session interactive. I'm joined here today by two extremely talented individuals, Ritvik and Orithro, who will be helping me tend to your queries. So I hope that my presentation is visible. So today, you all are here because you have chosen to go through our new and improved deep learning course. The intention of this session is to essentially act as a precursor to the actual fun. Of course, we also hope that you will get to interact with each other and make the learning part a whole lot more enjoyable. So without further ado, let's start. An introduction to the world of deep learning. Today, we'll be taking a little tour of deep learning and the countless number of beauties it has to offer. I'm Devjyoti, and as Ritik has already mentioned, I'm Devjyoti, and for today, I'll be your guide for this journey. First things first, let's go over what we will cover today. Of course, we'll start with addressing the first basic question: what exactly is deep learning? The next question accordingly becomes, why will we choose deep learning? Then, before we move on to our live session, we will once be going through the course overview of our deep learning course. Lastly, I'll talk about my own interpretation of deep learning, kind of like tips and mantras which I follow when I tackle real concepts. So the question of the hour, what is deep learning? To get there, let's take a small step back. Now, this is an image which you will find a lot in your DL journey. Basically, deep learning is a subset of machine learning, which in turn is a subset of artificial intelligence. And naturally, this obliges me to start with artificial intelligence or AI. Now, if you have the notion that AI means something like what you have seen in pop culture, like in Terminator, a sentient robot capable of human emotions, well, that is exactly what AI embodies, actually. It is the study of mimicking human intelligence in machines. Now, machine learning tries to accomplish this using statistical methods. Deep learning is an area of machine learning that deals with artificial neural networks, which are algorithms inspired by the structure and function of the human brain. So that is exactly what our end goal is, to be able to fully replicate the intricacies of a human brain. The most common image that you will see being associated with deep learning is this, a representation of the nodes in a neural network. You see how all the nodes of a layer is connected to the nodes of the previous layer. This is to signify that there is sharing of information between each layer. But what is inside those nodes? For that, let us zoom in. Here, on the left, we have a value. We have an input value, and we have named it as X. Inside the node, this whole thing is called a perceptron, by the way. But for now, inside the node, we have a value W, which we will call the weight. And on the extreme right side, we have the output value, which we will call as Y. This whole thing is represented by a very simple equation that is on the bottom right. that is y is equal to wx plus c. The c value I can see that it's new and it's not in the diagram. It's basically a bias. It's to adjust the weights. But if you see it hard enough, you will notice that this is basically the equation of a line in geometry. One of the first equations that you encounter. It is that simple. So small quiz time. What do you think the job of these nodes inside a neural network are? And I do not want a mathematical answer. I would prefer an intuitive one. So I'll wait for a while if anyone can answer the question. Well, we are on a time constraint, so I will just continue. So these nodes will try to help the network find patterns in the data that is fed to them. This enables them to make the correct predictions for a given input. We as humans can see the digit 1 and identify it from an image. But a machine will have its own way of finding a pattern such that it can identify the digit 1, and not only the digit 1, all the digits. Now that's enough talk. Let's see some applied DL. When it comes to applications of DL, the first thing that I show to people who are getting into the world of deep learning is this. This is one of the first projects that I had worked on during my deep learning journey with my colleague Aritra. Replication of images in the style of an artist's painting. Now, a lot of you might think, hey, they just took 2 images and combined them. And for that, I would ask you to look at it more closely. For those who don't know, this is basically Vincent van Gogh's famous Starry Night. And we have on the left, we have image of a dog. And the resultant image is the dog is as if the dog is being painted by Vincent van Gogh himself. Now, a few years back, this is actually an app came in the market and that made some huge impact. And that app was Prisma and they did the same thing. So now you know. But let me come clean here. By the time you will complete our course, understanding the logic behind this concept would be child's play for you. But at least till then, be amazed. But this is just a visually appealing attraction. What about a solution to a real-life problem? And now we come to one of my favorite applications. Who here can identify where the image on the left is taken from? It is actually from the Avengers, a movie which came out in 2012. Here, Iron Man is using state-of-the-art technology, in fiction, of course, to identify a missile's make and model through his visor. No one could have imagined that not only would we make this a reality, but go beyond that to a point where self-driving cars today are close to mass production. On the right, we have a live-action demo of an object detecting algorithm. And you can see by the amount of detections it is making by the second that we have certainly come far. Deep learning has revolutionized the world, but its biggest downside is corporations choosing to make merchandise like this. This is not funny and they should stop. And we should make a petition for them to stop. Okay, moving on. Our next topic is why deep learning. Now you must have your own reasons for choosing this, but let's go over some of the more common ones. You know how lucrative DL is, which is just another way of saying there is lots of money to make here. I'm not going to sugarcoat. Just Googling the 2021 AI market cap should be enough to understand what I'm talking about. But still, let me break this down in even simpler terms. Data is the new world currency. And at this point, we have more data to process than we have data engineers or scientists. Think about that for a second and what that means for opportunities. Now, this is one of the more common themes we see in our students, a change in career track. The previous slide kind of talks about it, but the bottom line is that the opportunities in deep learning are next to endless. If a data scientist tells you that deep learning is a dead-end domain, then my friend, that is not a data scientist, but a Java developer in disguise. No offense to Java developers, that was just done in good humor. Next is fascination with the subject. If you fall under this category, you do make our jobs a lot more easier because the winning recipe is dedication and interest. You may have the utmost dedication, but if you treat this subject like a chore, you're not going to go far. On the other hand, interest and no effort is going to be a downfall. You have to work hard, but also develop a love for this subject to succeed. We have the right resource, that is the course for you, but the option to use it to change your life, is still in your hands. Which brings us to our deep learning course, for which you all are here today. Let's take a quick look at what you will learn in the course. Take a moment to go through it. We have a very diverse and we have a very extensive syllabus. There's everything you need to know about starting with deep learning. And understandably, some topics may sound more interesting and not boring than others. And you might be correct in thinking some of these are much more cooler. But the reason that we have such an extensive syllabus like this is very simple. To stand out or to do something wondrous in the world of DL, essentially to go much forward, you need to have a rock solid foundation. Our course is aimed at hitting and strengthening your roots such that you will never second guess yourself understanding a concept. See, you can be one of those people who know a few lines of code and can run a neural network. Or you could be one of those people who not only know the lines of code, but know what is happening underneath. And we aim to make our students the second type. Finally, we have reached our live session. All theory and no practice makes Jack a bored boy, and we do not want that. I will be going through a code where we have created a simple neural network to identify digits from an image. So let us start. We will be coding in Python, and for people who are not very comfortable with Python, do not worry about that. I'll try to address as many queries as I can. And if I fail, do not worry, our deep learning course takes care of that. So yeah, our collab session is connected and now we can start. The first thing that we will talk about are imports. So for those who are not familiar with Python, I'm just going to try and break it down for them. Imagine this whole code session as a race. Your goal is to reach the end, reach the finishing line. These imports are essentially your allies who are going to provide you with tools that will help you reach your end goal. So we have NumPy. This is basically an ally which is going to help you in the mathematical side of things in your code. Then we have Matplotlib. This is going to help you plot your images. Then we have TensorFlow and Keras. This is actually our main friend. This is going to support us like this. TensorFlow, you'll find TensorFlow a lot here. This is basically giving us the data set as well as helping us create a neural network. So let's run this piece of code. So the data that we'll be using today is the MNIST digit data set. So normally, if this was 2010, we had to go through a very extensive process of finding the data set online, downloading it, seeing if it is in the right format, or as pre-processing it. But we are in 2022, and the data sets which have been in extensive use, TensorFlow has made it easier for us by hosting them themselves. So we can just call our data set using this particular line, mlist.load data. So yeah, we are taking help from our ally TensorFlow and calling the data. So we are calling the data using load data. But what do we do with it? The first thing we do is unpack it properly. Whenever you're training or working with neural networks, you know that you have to have a training data. You also have to have a testing data. So here, first we have unpacked our training data and training labels, and then we have unpacked our testing data and testing labels. Let's quickly run this snippet of code. And that's that fast. We now have the data set stored in our session. We indeed live in a very, very helpful era, trust me. The next important thing, like this is like data is probably the first pillar in building a neural network. The second is knowing what kind of shapes you're dealing with. Trust me, this might sound extremely childish, but this is going to make or break your code. So let's check out the shapes of our training data. The shape of our training images is that we have 60,000 images, each of height 28 and width 28. So if I go here, if I go here, imagine this is your height, this is the width, both are 28 for our images. For our testing set, we have 10,000 instances of testing data, each of height 28 and width 28. And of course, the number of labels will have to be equal to the number of instances we have. So the number of labels in our training data set has to be 60,000, and the number of labels in our testing data set has to be 10,000 accordingly. Now let's look at our data. This is also a very important part. You have to understand what kind of data you're dealing with. So here, if you are a bit confused with the code, do not worry. So essentially what we are doing here is we are essentially just defining space and defining a space for our plotting our figures. We are also defining space and the figure size. One thing that you will encounter in Python a lot are loops. Now think of loops as time loops. You cannot break through the time loop until a certain condition is fulfilled. So that is exactly what we are going to do here. Here our for loop will run 5 times. But it has run once, it will not break. It has run twice, it will not get out. Third, no. Fourth, no. Finally, the 5th, it will get out. So this will run 5 times, and each time we are going to grab one set of training data and plot it. So here you can see that we have in a column, we have in a row, we have training data, and you can see that since the images are so small, 28 or 28 is not, it's not big at all. The images are very kind of grainy. On top of each image, we have the label of the image. When we are doing what we are accomplishing here is supervised learning. Again, this terms are terms you will encounter a lot when you will go through the course. For now, don't have to focus too much on that. So here we have the image, and on top we have the label. So 5 with a label of 5, 0 with a label of 0, 4 with a 4 accordingly. Now we have 60,000 instances of these images right now for training, and that's a lot. The next thing that we are going to do is a concept called one hot encoding. Now for that, I am going to go to my trusted, helpful website called diagrams.net. So imagine we are dealing with an image which has the label 4. That is a single label, and we do not want that. We want for our neural network to work with all the 10 classes at the same time. So this 4 can be represented in this format. Now, when we are dealing with computer science data structures, we always start with the 0th index. So count with me: 0, 1, 2, 3, 4. Now you can see that this is the whole size of this little box structure. This is just know that this is called a vector. So the size of this vector is 10, and all the indexes have the value 0 except for 4, where we have 1. So if 6, we'll go from 0, 1, 2, 3, 4, 5, 6. We'll change the 6th index to 1 and the 4th index to 0. So this is essentially what one hot encoding is. And since our label are now like single value, we are going to just stretch them out in one hot encoding format. For that, first we will define an empty list. Now, for people who do not know Python, um, just imagine lists as a suitcase where you have to insert things in an ordered fashion. So we have created an empty list, and we're going to loop over all the instances of labels inside Y-train. That is basically the training labels. Inside it, we are just going to use a tool that our ally TensorFlow has given us, like utils to categorical. That's what it's called. So it's going to just take this and give input this and output this. So it just does the work for us. So, and we have to also specify the number of classes because we are dealing with 10 digits, 0 to 9. That's why our number of classes are 10. And once we have turned all of our labels into one hot encoding, we are just going to turn them into numpy arrays, which for now just know that those help for easier and efficient mathematical calculations. So we have done this for our training labels, but we have to do the same thing for our testing labels too, right? So we have just repeated the same process, just that here we are going to loop over the test labels instead of the training labels. So now our labels are ready. Next is probably the thing what you have been waiting for, that is the neural network. So again, our ally TensorFlow gives us almost everything we need, like almost everything we need for our neural network. So accordingly, first we have to define that our network is sequential, and this just means that the layers that we will add in our network are one after the other. We have a question here. Do you always need to know the number of classes at the start? Yeah, you need to know the number of classes at the start to apply one hot encoding. And probably no matter which data set you deal with, nowadays data sets are so well documented that you will know that. Do not worry about that. Okay, so sequential model here, that means one after the other. So first layer that we add here is flatten. Now let's get back to our slides. So here we have a 2D array of 4, like of height 4 and width 4. So it's essentially a square. Images at their base form are just these arrays and a number representing their pixel. So just treat this as an image for now. When I will try to flatten it, what we will get is a long single 1D array of size 16, because 4 into 4 is 16, and we will basically be losing the 2D representation, but we are going to get a 1D representation instead. Now I will have a question on this posted to our listeners, but for now let's move on. So we are going to firstly take our image, which is 28 cross 28. It's in a 2D array format, and we're just going to flatten them. And when I flatten them, their shape becomes 784. So what do I mean by that? Let's look at the very first image of a neural network that we had seen here. When I now have a vector of size 784, what I mean is that we will have 784 nodes like this in the input section, one for each pixel, assigned for each pixel. So that is why we are flattening it, and we also know the shapes here. You can also work with the image in its 2D format, but that's something that I'm leaving right now because that's something that has been extensively discussed in our course and would probably take me more than 1 hour to I'll probably exceed the time limit. So let me not spoil all the fun here itself. Okay, so once we have flattened our image and made it into a 784 length 1D vector, the next thing that we do is add a dense layer of size 256. So that means that the second layer that we add here, we'll have 256 nodes like this. If I try to add it in this image here, probably we won't be able to do that. So yeah, 256 in the second, like, nodes for our second layer. And finally, we'll need to have an output layer, for which we need to have the number of nodes equal to the number of classes. So here, that's why our final output layer has 10 nodes, because we have 10 classes. So let's run this snippet of code. And we also have a little bit of helping function here called model.summary, which is going to help us look at the complete overview of our model. Okay, so the 28 cross 28 2D array goes in, gets flattened, and now the shape of the our input is 784, which then is going to encounter a layer which has 256 nodes. So the number of parameters becomes 784 into 256. Then that is now going to encounter a layer which has 10 nodes, which is our output layer. So the total number of parameters we have is like 200,000, 3,530, and you might think that is a very big value, but trust me, once you start working in deep learning, you're going to encounter much big data sets, and this value is going to reach millions and billions. So this is nothing, trust me. So now that we have defined our model, next we have to just specify a few things. And some of these things you probably will probably not know, so I will not be focusing too much. So first thing that we have to do is specify the loss function. The loss function is the most important piece of your model, because it depends on how much more your accuracy will be, or how fast it reaches, how much it reaches, how fast it decreases essentially. So today we have categorical cross entropy. This is, again, you don't have to worry about this. It's just because we have one not label encode, and then we have an optimizer. This is just, think of it as another ally which is going to help you get the loss value down. And for our matrix, we are choosing accuracy. That is, more the accuracy, the way we will know that our model is working. So let's run this snippet. So our model is absolutely ready. The next thing that we have to do is fit our training data inside the model. So let's do that. Okay, so one thing I'm doing here, like in this function, you can also see something like validation data. So what happens in each iteration, your model is going to train on the data, training data, and the weights will be changed. The training on the training, the training data is going to affect the weights of your model. But then we also have something called validation data. In each iteration, you'll also get a validation accuracy, but the validation data is not going to affect the weights of your model. Now, my colleague Aritra would probably probably berate me for doing this. What I'm doing here is a cardinal sin. Is basically giving our testing data as our validation data. You see, every time we do some practices that you should follow is, every time when you are working in with a neural network, you should have three data. That is the training, the testing, and the validation. Here I have just treated my testing data as validation because, for simplicity's sake. But yeah, let's move on. So our training is going to run for, sorry about that. Yeah, that's one thing that you need to get accustomed to, getting errors left and right. That is part of being a coder. You're going to probably encounter more errors than you have ever when you're coding, when you first started coding in deep learning. So that's normal. Don't need to beat yourself up for that. As you can see that we're not even like half, we've not even crossed half the epochs, and already our accuracy is 92%, which is a good thing when you're working with neural networks. It's probably the best site you want to see. So that's great. It tells us that our little neural network works. So yeah, so our training is now over. Let's see the predictions with our own eyes. That is basically that we are passing the testing data basically. And as you can see, I cannot make out anything that is inside. Like I cannot understand one thing that our predictions are trying to tell us. That is because these are unrefined. To get proper predictions, I'm again going to call my ally NumPy, who is going to give me a tool. And with that, I'm just going to get one prediction for each of my test image. And do not worry, we're going to see that with plots right now. Again, first, I'm going to assign a bit of area for our plots. Then I'm going to start a loop and just plot our predictions one by one. Okay, so let's go over this. Like each entry in this row essentially is one testing image, and on top is what our model has predicted. So a 7 is predicted as 7, 2 or 2, 1, 1, 0, 0, 4, 4, 1, 1, 4, 4, a 9, a 9, and oh, we should congratulate ourselves because our model has predicted all the test images in this particular batch correctly, which is a pretty great thing. So let's get back to our slides. Now, congratulations. You guys, you and I together have built a neural network which identifies digits from images. Now, I want you people to sit back and understand the implications of what you have just accomplished. Again, you have taught a machine to identify digits from images. Just imagine if you change the input data to number plates, you have successfully helped your city's law enforcement because now your model can automatically identify numbers in a number plate. Imagine if you can change the input data to images of cars. Voila, some tinkering, and you can use it in traffic. And congratulations, you have made your roads safer. DL has widespread impacts, even on things you probably see on a day-to-day basis. It is a powerful tool which has major implications on how today's world works. What we want, what we intend to do essentially, is to teach you how to harness this power. So, the final topic for today's session, an interpretation of deep learning, which is another way of saying my interpretation of deep learning. So, a problem I face almost in most DL assignments is understanding them flawlessly in just a few tries. And I hope my bosses who are watching this do not start doubting me for that. Sorry, jokes aside. Understanding DL concepts can be a mammoth task. Going through research papers, trying to figure out the mathematics, it can weigh you down. Trust me. It can make you feel like you are not smart enough. I have a simple mantra that I remind myself every time I feel that I cannot overcome a concept. It is understanding that beneath everything, it is just numbers. A digit can only be something from 0 to 9. The moment I remind myself there isn't some magic going on, there isn't some super duper archaic magic going on, I feel grounded. Because in the node of every neural network, there is nothing but the simple equation of a line. This is the very first equation that you learn when you have started studying geometry. And that's how simple it is. The moment I remind myself these things, I find my center again. I can tackle a concept from scratch again, try again, I can fail again. Yeah, that is going to happen a lot. But you're eventually going to overcome it. Because the main idea or the main thing that you have to understand is that you should not give up. The possibilities in DL are just endless. You and I together just created a small neural network which could identify digits from images. Now you could be working in an industry, in a company where you are working with the same code, scaling it up to deal with billions and billions of data. Or you could be thinking, well, no, the code I use, the formula I used, it wasn't efficient. I can think of something better. So you could be one of those who come up with something much more efficient, revolutionizing. And that happens every day in DL. So the possibilities, they are just endless. So thank you everyone who has accompanied me till now. For that, we have a little token of appreciation for you. We are giving 30% off on our DL for CV book exclusively for this session. You can use the QR code, or you can use the coupon code mentioned here. If you want, we will obviously send you the slides for this. Don't worry, whatever content there is in this book doesn't overlap with whatever content we are going to teach you in the deep learning course. So what's next? That is the question I would have had if I was sitting through a boring session like this. So the answer is simple. You can never stop. You can pace yourself. You can choose your own pacing. That's something everyone should do. You do not need to rush everything. But you cannot stop. The hustle never stops. The DL world keeps on growing every day. Love it, and you will be like, you won't be able to live without it as your day passes. Thank you everyone who has sat through this lecture. And I would like to thank each and every member of the PyImageSearch team for giving me this opportunity, especially Ritvik for continuously making sure that I created and I made sure my work was done on time, and also Aritro. So thank you so much everyone, and I hope you have a great time.